In this video, we'll look at some examples of factoring by grouping. This is a factoring strategy that may apply to polynomials that have an even number of terms, say 4 terms or 6 terms. It doesn't mean that factoring by grouping can always be used for those polynomials, but in some specific instances it is helpful. So here's a 3-step process for factoring by grouping. First, we're going to pair the terms. Then we're going to factor the greatest common factor out of each pair. And third, we're going to look for a common binomial factor that we can factor from each expression. So pairing the terms. With this example, I'm going to put these two together in a pair and these two together in a pair. There's more than one way that this could be rearranged to pair it, but I'm just taking it in the order in which it's written. Second step, factor the GCF from each pair. So as I look at these two terms, they have an x squared in common. That's the GCF. Let's factor that out and write what remains. So we've rearranged our first pair in factored form to look like this, x squared times 2a plus b. The second pair, there's a greatest common factor of negative 2y. I'm choosing to factor out the negative sign along with the number 2 so that this first term ends up being positive. So I have negative 2y factored out of this pair. What remains is 2a plus b. Notice that as I factor it in that order, I see a common binomial factor appearing in each of the terms. This has 2a plus b and this has 2a plus b. So that in itself becomes a greatest common factor that we can factor out. That's the third step. Let's factor out that common factor of 2a plus b. And what remains is the front part of each of these terms, x squared minus 2y. That's what remains when we factor out that 2a plus b. So here's the final result of factoring by grouping. 2a plus b times x squared minus 2y. That's the factored form of this polynomial. Notice that I did not write the 2a plus b twice. I factored it out. You only write it once, not twice. And then I wrote in another set of parentheses the remaining pieces, the x squared minus 2y. Let's follow the 3 steps with another example. So first I'm going to pair these terms. Second, I'm going to factor the greatest common factor from each pair. So here the greatest common factor is clearly b, and I'm left with 3 minus 2c. It's a little less clear here what to factor out. We know that there's a greatest common factor of 5, but should we factor out positive 5 or negative 5? Well, this depends on what I'm looking for in the third step. Remember, I want there to be a common binomial factor. So let's factor out a positive 5. Then this result is negative 2c. This result is plus 3. Now, are these the same? Yes, they are. They're just written in a different order. 3 minus 2c is the same as negative 2c plus 3. So if we want to rearrange terms, I can rewrite this last factor as 3 minus 2c. So factoring out a positive 5 here preserved the 3 as positive and the 2 as negative, and now I have a common factor that I can factor out in step 3. Let's factor out 3 minus 2c and write what remains, which is b plus 5. This is the factored form of our original polynomial.